You've got antivirus software, right? Of course you do. But what's really protecting your computer at its deepest, most fundamental level? Turns out, it's this tiny, powerful chip, a silent guardian you might not even know you have. We're talking about the Trusted Platform Module, or TPM. And we're going to dive into why this little piece of hardware is so incredibly important for your security.
So we all get it. You run your security software, it scans your files, it checks out your operating system. That's pretty standard stuff. But what if a threat could sneak in underneath all of that? I mean, what if something could infect your machine before Windows or Mac OS even has a chance to load? Well, that's a real thing, and it has a name: firmware rootkits. And trust me, these things are nasty. We're not talking about a normal virus here. These rootkits dig deep and infect the most foundational code on your computer, the stuff like UEFI or BIOS. That makes them pretty much invisible to your antivirus. And get this, they can survive everything: reboots, reinstalling your OS, even swapping out your hard drive. They just stick around.
Okay, so how on earth do you fight a threat that your software can't even see? Well, you have to fight a deep-level threat with a deep-level solution. You fight it with hardware. And this is where our hero, the TPM, finally makes its entrance.
So what is a TPM really? It's a special little chip, a dedicated security processor that's physically separate from everything else in your computer. Its whole reason for existing is to create what's called a hardware root of trust. You can think of it as an unshakable anchor for your security, something that malware just can't mess with because it's not part of the main system. Yeah, the easiest way to think about it is like a tiny, super secure vault built right into your device. But it's not just a dusty old safe. This is an active vault. It doesn't just sit there storing secrets, it actually works with them. It does all the sensitive crypto stuff inside its own protected walls. So, things like your encryption keys, they're generated and used inside the vault, never ever exposed to the outside world where malware could grab them.
Okay, so we have this secure vault. Cool. But how does it actually, protect your computer when you hit the power button? Well, this is where its main superpower comes into play. It forges this unbreakable chain of trust every single time your machine starts up.
And this whole process has a name. It's called a measured boot. It's pretty much what it sounds like. Every time you start your computer, the TPM is there, measuring every single step of the boot up process, creating this perfect, unchangeable record, like a unique digital fingerprint of the entire startup sequence.
Here's how it works. It all starts with a little piece of code in the firmware that we know we can trust. That's our anchor. Before the next piece of the puzzle runs, say the bootloader, that anchor measures it. It creates a digital fingerprint, a hash, and hands it over to the TPM to store. Then, that component measures the next one, and that one measures the next one, and so on. You get this perfect, unbroken chain, a verifiable log of exactly what happened when your computer turned on.
Right, so you might be thinking, that sounds complicated. Why bother with all that? Why create this whole detailed digital record every single time? Well, the answer is this incredible feature called sealing. And honestly, this is where the real magic happens.
The TPM can take super sensitive data, like the key that unlocks your encrypted hard drive, and seal it to that unique boot fingerprint it just created. That key will only be released, or unsealed, if the boot process is exactly the same as the last time. So if a rootkit snuck in and changed something, well, the fingerprint changes. The TPM sees the mismatch and just goes, nope, it refuses to release the key. And just like that, your data stays locked down, completely safe.
Okay, so that's the how, the technical nitty-gritty. But let's bring this back to reality. Let's talk about the what. How does this awesome little chip actually show up in the features you and I use every single day? First off, you gotta know that not all TPMs are created equal. The standard we all use today is TPM 2.0, which has been around since 2014, and it is a massive leap forward from the old 1.2 version. We're talking way stronger crypto algorithms for one. But the real game changer is something called algorithm agility. Basically, it means the chip isn't stuck in the past. It can adapt and use new, stronger security algorithms as they're invented.
And that huge jump in security? That is exactly why you heard so much about it a few years ago. It's the reason Microsoft made TPM 2.0 a mandatory, non-negotiable requirement for Windows 11. They were basically drawing a line in the sand, saying this is the new security baseline to fight back against exactly these kinds of deep-level attacks.
And once you know what to look for, you can see its work everywhere. You use BitLocker to encrypt your hard drive. The TPM is the guard dog watching over that key. You log in with your face or your fingerprint using Windows Hello. Yep, The TPM is protecting that biometric data. It's even the hardware anchor for the future of logins, those new passwordless passkeys. It holds onto your private key so it's literally impossible to phish. And for anyone in a corporate job, it's what proves your device is trustworthy enough to connect to the company network.
Okay, so the TPM is obviously a powerhouse. But, in the world of security, nothing is ever 100% perfect. So we have to ask the question, is it unbreakable? Are there any chinks in its armor?
The short answer? Nope. It's not perfect. It gives you a massive security upgrade for sure, but it's not infallible. Researchers have definitely found ways to attack it. Now, before you panic, most of these attacks are way, way beyond the skills of your average hacker.
We're talking about some seriously high-level stuff. There are physical attacks where you need a lab full of expensive equipment to literally rip the data off the chip. Then there are side-channel attacks, which is super clever stuff where they analyze tiny clues like how much power the chip is using. What's a bit more realistic, though, still pretty rare, are bugs in the TPM's own software or mistakes a manufacturer makes when they build the computer. These are serious for sure, but again, not something the average person needs to lose sleep over.
But here's the good news. Manufacturers are always on the lookout for these things, and they're constantly releasing patches. And that is why it is so important to keep your device's firmware updated. You know how you update your apps and your operating system? You got to do the same for your firmware. It is the single best thing you can do to protect yourself from these kinds of advanced threats. All right, let's wrap this up by looking to the future, because the TPM isn't just about making our laptops safe today. It's really a foundational building block for the security of, well, everything tomorrow.
I mean, its role is about to get a whole lot bigger. Think about the Internet of Things. Every single smart device, from your fridge to the traffic lights in your city, is going to need that hardware anchor of trust. The TPM is perfect for that. It's also being connected with AI to create much smarter ways to detect threats. And remember that algorithm agility we talked about? That's going to be crucial for the future, so it can adapt to things like post-quantum cryptography when our current encryption methods just don't cut it anymore.
So, I'll just leave you with this. This little chip went from being a niche thing for big companies to a standard feature that protects billions of our devices. As everything, and I mean everything from our cars to our coffee makers, gets connected to the internet, this whole idea of a hardware root of trust is going to be more critical than ever. The silent guardian in your computer? Yeah, it's really just getting started.